As the amount of data you're working with increases, it becomes harder to eyeball it and identify patterns in the data or relationships between the variables. This is where data visualization comes in. A picture is worth 1,000 words and definitely worth 1,000 numbers. A chart, a map, or a scatter plot can show you things that you might potentially miss. We use data visualization both as a tool for exploratory analysis to uncover what the data reveal, and as a tool for building a narrative, a story that you can share with an audience and help them to see what you see. When you start to work with your data, it's important to understand the story you're trying to tell and the relationships you are looking to show. Knowing this information will help you select the proper visualization to best deliver your message. When analyzing data, search for patterns or interesting insights that can be a good starting place for finding your story. A simple scatter plot, like the ones you see here, can be very revealing. By plotting a variable such as sales over time, you can see the trend in sales. For example, the first scatter plot shows that ice cream sales are falling over time. By plotting two variables that are likely to be related, such as ice cream sales and temperature, you can see the correlation between them. For example, by separating sales on high temperature days from sales on low temperature days, as in the second plot, you can see that sales increase when temperatures are rising and decrease when temperatures are falling. A scatter plot can also show outliers, that is, observations that are extreme in some way. The third plot shows that sales in some regions are unusually low compared to others, and it may be useful to investigate reasons for those outliers. As the amount of data available to us increases, it becomes more and more important to find ways to tame it by visualizing it. Otherwise, it becomes just a blur of numbers that do not yield any actionable insights or conclusions. This table shows sales in two chains named Fashions Direct and Next Look by product type, month, store location, store manager, and buyer. Looking at the numbers in this table, it's impossible to know what to take away from it. The same data table that you just saw is far easier to comprehend when you plot it. In this case, we use a bar chart to show how sales for the two chains vary by product type, and a line chart to show sales trends over time. As the charts show, sales for the Next Look chain are much higher, especially for categories like home, kids, women's, and groceries. Over time, they pretty consistently follow the same pattern of peaks and valleys. When you are deciding what type of data visualization to use, you need to think about a number of factors that will affect your visualization strategy. First, what types of data do you have? Do you have categorical variables, also known as nominal variables? That is, which categorize observations into groups? Or do you have quantitative variables, which measure something numerically? Second, what relationships or patterns do you want to show? A trend, a comparison between groups, or a correlation between variables? Lastly, you must also have an understanding of how people perceive things visually. In the next few slides, we will examine these in more detail. Looking first at the type of data, your data may consist of categorical or nominal variables which are used to categorize observations into groups. For example, gender, zip code, type of product sold, etc. Or you may have quantitative variables, that is where something is being measured, such as inches of rainfall, height, weight, etc. Quantitative variables in turn may be discrete or continuous. A discrete variable can only have fixed values. For example, the number of employees in the office can only be 1, 2, 3, etc. A continuous variable can have an infinite number of values. For example, the weight of an object can be 5.1 pounds, 5.25 pounds, 5.375 pounds, etc. Some charts, such as bar charts, require there to be at least one categorical variable, which was product type in the earlier example, while others, such as line charts, require a quantitative variable, such as sales in that example. The second factor to consider is what pattern or relationship you want to show. For example, if you want to compare groups, at least one variable has to be categorical, that is, nominal, and you could use a bar chart. If you want to show a trend or time series, the horizontal axis needs to be some unit of time, day, week, month, etc., and the vertical axis needs to be quantitative, for example, sales. a line chart would be effective for this purpose. If you want to show a correlation between two variables, then both variables need to be quantitative, and a scatter plot or line chart could be used. To show a part-to-whole relationship, for example, the percent of customers purchasing different products, you need at least one categorical variable, and a pie chart would be the most effective. Finally, to show the relative magnitude of a quantitative variable for different groups, a bar chart showing the rank order of values would be useful. Let's pause for a moment to discuss how to create charts in Excel, in case you're not sure how to do that. I won't try and explain the process in the video here because you might already know how to do this, and there are many excellent tutorials already out there. Here's one you could try, but feel free to shop around if you want something different. Next, let's look at visual perception and how it works. When people look at a figure, certain attributes stand out and are noticed even before you consciously pay attention to them. These are called pre-attentive attributes. In this example, if you try to identify each instance of the number 5 in this list of numbers, it's not easy. You have to go through the list one number at a time, decide whether it is a 5, and then move on to the next number. But if you change the color of the number 5 to be different from the rest, you don't have to look at each number because color is a pre-attentive attribute. With one look, you can identify all the 5s in the list. Length is a pre-attentive visual attribute. Your eye is instinctively drawn to the longer bars in this example. Shape is another pre-attentive attribute. This scatter plot shows the relationship between ice cream sales on the vertical axis and expenditure on TV advertising on the horizontal axis. Looking at this, it seems apparent that there is no relationship between the two variables. But if we add more information to this chart, it becomes crystal clear that there is a relationship between sales and advertising. We need to distinguish between hotter days and colder days, defined as days where the temperature was either above or below 30 degrees Celsius. If we assign a different shape, a filled-in circle as opposed to a hollow circle, to observations on hotter days, the relationship immediately jumps out at you. Color, of course, is a pre-attentive attribute too. Here's an example of how we can draw attention to states with higher sales just by using gradations of color. Lower sales are in a lighter shade and higher sales are in a darker shade. Here's another example of the use of a color gradient to draw attention to products with higher sales. Again, higher sales are shown by darker shades and the eye immediately goes to them. In summary, here's a cheat sheet showing some common ways of using visual attributes. You can use any of the following ways to draw attention: form, color, and position. When you want to draw attention to categorical data, color and shape are useful attributes to focus on. When you want to draw attention to quantitative data, length, size, and position are useful attributes to consider. Now, these are not hard and fast rules, however, so if you find some other way of depicting data, go with whatever makes sense to you. That brings us to the end of this module, and in the next module, we'll take a deeper dive into different types of charts and look at some of the best practices in their design.